So in this last triad exercise of the section, we're looking at factoring by grouping, only the difference is we have like terms as our two middle terms. Now, you wouldn't have to use this method, factor by grouping, for this polynomial. If you look at it, you have x squared plus 2x minus 5x is minus 3x minus 10. And how we've done that in the past is what multiplies to negative 10 and adds to negative 3. Well, that would be negative 5 and 2. But this shows that you could create factoring by grouping by adding and subtracting like terms that would yield this minus 3x. And also notice that we're just in these instances looking at terms with common factors. We could rearrange this to be x squared minus 5x plus 2x minus 10 as well. It's the same polynomial, and it all comes out in the wash. And I'll show you that that would actually work as well after we look at factoring by grouping. For the first two terms and the second two terms, we have a common x in the first two terms, so x times x plus 2, and then plus negative, or we could just say minus, and the common factor in 5x and 10 is going to be 5 times x minus 2, or excuse me, x plus 2, because we have the negative out here, so negative 5 times x, and then negative 5 times 2 would be negative 10, so x plus 2. And that equals, factoring out the x plus 2 times x minus 5. Now, what I said earlier was if we had this as x squared minus 5x plus 2x minus 10, this is the same polynomial. Negative 5x plus 2x is still negative 3x. And the only difference is we're going to factor out the common factor and end up with the other binomial as the common factor in both groups. So again, this would be x times x minus 5 plus 2 times x minus 5. Then factoring out the x minus 5, we get x minus 5 times x plus 2, which is the same factorization we got before, just the order of the binomials is reversed. Now on to part B. Similar type of problem. We've got the two common terms in the middle. This would end up being, and this is where this method might come in a little bit handier, is when your leading coefficient isn't 1. And when we end up with a middle term that is a little bit more complicated, because then we can't just use the method of what multiplies to 12 and subtract. We'd have to factor out a 20 or use different methods to factor this. So this does come in handy here. We'll group the first two terms. Our common factor is going to be, what's the common factor of 20 and 16? That's going to be, this is 4 times 5, this is 4 times 4, so it's going to be 4. And then the common factor of x squared and x is going to be x. We're left with 5x minus 4x times what makes 16x. That would just be 4. And then we're looking for minus, what's the common factor of, now remember we're going to be changing this, let's go ahead and write our parentheses here. Because we're factoring out the negative, we have to change this to a minus, because we want the 12 to be positive. So what's the common factor of 15x and 12? It's going to be, this is 3 times 5x, and this is 3 times 4, so it's going to be a common factor of 3. And what's left in parentheses is going to be negative 3 times what makes negative 15x. That would just be 5x. Hopefully we get what we got in the beginning. And then negative 3 times negative 4 equals 12. And then we factor out the 5x minus 4, so we end up with 5x minus 4 times what's left, 4x minus 3. And again, as a check, I'm going to go ahead and rewrite the order and make sure I end up with the same thing. So 20x squared minus 15x minus 16x plus 12. I just reverse the order of the two middle terms. That equals, what's the greatest common factor of 20 and 15? That's going to be, again, 5. This is 5 times 4 is 20, and 3 times 5 is 15. So this is going to be times 4. What's the greatest common factor of the x terms? That's going to be x, so I need to put that out here as well. And then 5x times 4x equals 20x squared. And then minus 5x times 3 ends up being negative 15x. And then minus, so the greatest common factor is 16x and 12. That's going to be 4 times, remember we have to change the sign again. It's going to be subtraction, so we end up with a positive 12. And then we end up with 4x minus 4 times 3 is 12. And we end up with the same thing we had before, the 5x minus 4 times 4x minus 3. So we know that this is the solution, because in both instances we got the same factorization.